Problem number 2 from projection of solid. Here the terms you have to find out is what is it, which plane it is, where it is, and how. So first of all, which plane, which solid is square pyramid. Side dimension is given to you, is freely suspended from one of the corners of the base. Okay, in this they have not mentioned it is resting with HP with its corner or anything. They have just said that it's freely suspended. Freely suspended, that means if this is a square pyramid or anything, if I put my point here, so this is freely suspended. It is not touched to the ground, it is not stick to the floor or anywhere. It is freely suspended. So if it is freely suspended with one of its corner, then the top view gives you the true shape. So that is the first thing, because we don't know the how it's look like. So first of all, we have to complete our initial position. So let's start with the initial position. So XY line, draw XY line first. Then it is with respect to corners, then you have to draw a corners first. So to draw the corner, the angle, the lines is 45 degree with each other, means, so measure the angle of 45 degree both the side to construct a square. And the base side or side of the square is 40 mm. Then draw a line at 40 mm distance. This is the one side. Then second one is somewhere here. It is also 40 mm. You have to complete your square by drawing parallel lines. So this is the square which is resting with its corner. So this is the pyramid. So this is the pyramid. If you observe it from the top, you can see the center point. So you have to find out the center point also here by joining the diagonals with the thick line. It should not be drawn with the thick line, thin line. So these are the diagonals. So this point is your center point. If you observe it from the top of the pyramid, you can see this apex point. So and these are the points A, B, C and D. So this point is O point. It's a center point. Then front view is a triangle. So draw the projections. And the triangle is the height of 64 mm, which is given to you, the axis height. So you have to measure a distance of 64 mm and draw a vertical line. So this is your edge, first edge, and this is an apex point O dash. And then if you join it with the corners, this will gives you the front view of a square pyramid. So this point is A dash point, this is B dash and D dash, and this is a C dash. So this is my initial position, which they are not asked to draw, but you have to draw it to find out the intermediate or the second position, which is the plane, the solid is freely suspended with its center point or the corner point. So one of the corner is this. Freely suspended means when you lift your solid from this corner, let's say, just pick it up this corner and just do gravity its work. So when you pick up your solid with this corner, and whatever the position it will got, that is a freely suspended position. So you have to find out center of gravity, CG point, to find out the second position. So to do so, you have to find out, to find the CG point, you have to find a midpoint of this corner, this generator. So midpoint of this is the 7 centimeter long line. So midpoint is, let's say, 3.5. so this is a midpoint and joined with that corner. So this corner is like this. So you have to draw it very thin line, and this point is your CG point, CG. Now if you pick your solid from this line become a straight line, because the center of gravity make its work, and it's freely suspended in the air. So in this intermediate position, or what the position they have asked to, you have to draw this in a straight manner. So first of all, we have to draw a straight line which gives you the center of gravity. So this line is nothing but, let's say, this point is A point, this point is A dash point. So you have to construct the whole structure with respect to this, and let's say we are going to measure this distance, a CG with the A dash point, for better understanding. So this point is your CG point. By taking these two as a reference, you have to construct a whole front view in this view. So to construct whole structure over here, you have to measure this which you have drawn here, center line, CG line. You need to construct this line. So you have to measure this angle and length of this line. So by using this two, you can draw a line over here by from A dash. So let's measure an angle. So the angle is around this one, 37. 37 is your angle. So you have to draw a line at an angle of 37 degree from this. So this is your point, and this distance you have to measure, which is 5.5. So you have to draw a line at angle of 37, and the length is 5.5 or 55. So this line is this. So this point is C dash. Now you have to find out a center point. So which is from A dash, it's a B dash D dash. From A dash, it's a this B dash D dash. So B dash D dash. You got this line. Now you can see here, this B dash D dash is passing from CG and the height is 64. So you have to draw a line which is passing from CG and at the distance of 64. Like this. So I have draw this line to find out my O dash point. So I have draw this vertical line. Now you have to connect all the corners like this. So this is how your solid is freely suspended at the point of A dash, which is a corner they have asked to. So this is the intermediate position, or we can say the starting position, because we don't know how to draw the directly, so we have to draw this first. Now if you want to draw the top view, then draw the projections and find out the intersecting points. Now find out the intersecting points. A dash is over here, so this point is A, B, C and D, and this point is O point. Now join them. So this is the base of your pyramid in a top view. Now joint with O every corners. You have to make sure the hidden lines also. So now from the top you can see this edge, but this is a solid surface, so you cannot see the backside of the edge which is connecting C to O. So but by using the line importance, you have to select a straight line over hidden line. So C to O is a totally dash line, but A to O is a solid line, so that's why I draw a solid line here. But here you have to construct a dash line which indicate a edge of C to O. So this is your position in which our solid is freely suspended. Now draw its projection when vertical plane VP containing the axis makes an angle of 45 to the VP. So this axis here, this is the axis, so this axis and making an angle of 45 degree with the VP, so you have to rotate this at an angle of 45 degree over here. So this is right now it's parallel to XY line or a VP, so make it 45 degree. So first of all we are just draw a line at an angle of 45 degree. Now you have to construct this rectangle here with the same dimension which here we have. So let's start with this line, because we have already this line. So it's around 6.8. So C to O point is a 6.8. So let's say this point is my C point. Then measure it over here, the 6.8. I make it at some distance because it will not going up. So this point is C point and this is my O point. Now to construct a rectangle you have to draw a perpendicular line from this, so here, and the measurement is around 5.6. So draw a perpendicular line from C and O. So 28 both the side. Draw complete a rectangle. Now you have to draw this line, you have to make a divisions of it. So this is the corner. We need this line as well. draw the lines passing from that points. Now find out the intersecting points. So this point is a C, this is my B point, A point, and this is D, and we have already got O point. So now joint all of them. See, this is not the only method. You can draw it with the different method also, but this will give you an accurate result. You can measure, you can first of all draw this rhombus here with the proper dimensions, whatever the dimension it has, and then complete the shape. But in that you have to measure so many dimensions. So I have completed this here. Now you have to draw the projections from this position and this position and find out the intersecting points. So find out the intersecting point. Make sure this is a freely suspended solid. So your solid should not be touched to the XY line at any point of the time. In first position, this is not a position actually. To achieve this position, we need a shape and dimensions of initial position. But in the rest of the views, you cannot touch your solid at XY line because it's a freely suspended in the air. So let's find out point A. So this point is my A dash point, B dash, C dash, and D dash, and this is my O dash. So be careful with the hidden lines. So first of all, complete the square because we can see the whole square from this. Now joint all the corners. You see, this edge is visible, this edge is also visible. This is back side, so this is also visible because it is little bit tilted. So this line is also visible, but this line you cannot see this line. So this edge is hidden. So only one line is hidden here. Rest of the corners and edges we can see. So this is your initial position and this is your final position. This is the problem number 2 from projection of solid.